Hello everyone. I welcome you all to RG Learning Academy. In today's video, we'll be starting off with a new series wherein we'll be discussing solutions to various common entrance test questions which have appeared in various subjects. So in present video, we'll be discussing a solution pertaining to the mathematics question which has appeared in CET 2025. The problem is associated with counting 4-digit even numbers. So the question which appeared in CET 2025 was find the number of 4-digit even numbers that can be formed using digits 0, 1, 2 and 3 without repetition. So when we observe the question, the key takeaway points over here is that we need to find a 4-digit even number and we need to use the digits 0, 1, 2 and 3 only. And another key point is that in the 4-digit number, these 4 digits should not be repeated. So the concept associated with the problem is that we have these 4-digit numbers and we should form a 4-digit even number and there should be no repetition. So if we all know that the even numbers out of these four will be ending with 0 or 2 only. If the number is ending with 1 or 3, then it accounts as a odd number. So hence your digit, whatever 4-digit number we are forming, should be ending with 0 or 2 only. So hence we can divide this problem into two cases. That is, in the first case, we can identify how many number of 4-digit numbers can be formed which are ending with digit 0, and similarly how many number of 4-digit numbers can be formed which are ending with digit 2. So let us check out what will be the solution. So let us consider the first case wherein we'll check out how many numbers can be formed wherein the 4-digit number is ending with 0. So hence the choice for the last digit out of the 4-digit numbers, so what we are forming will be 0. So one of the digit is utilized and it is fixed. Now we need to decide what will be the remaining 3 digits. So we have, for remaining 3 digits, we have the choices 1, 2 and 3. So out of these 3, if one of the digits is chosen for this first place, one of the digits is chosen for the first place, then what we have is that digit cannot appear in second and third digit place. So let us consider, for example, if I choose 1 as the first digit out of these four numbers, then I am left out with 2 and 3 only. So I can choose only these two numbers and I can arrange them to have a 4-digit number which is ending with 0. So how many ways I can choose this first digit? There are 3 possible digits over here, and since there is no repetition permitted, I can place a digit over here in only 3 possible ways. I can place this in 3 possible ways only. Now what about the remaining 2 digits? So remaining 2 digits can be occupied with number 2 and 3 when I am considering 1 as the first digit. So 2 and 3, if I just observe, I can place 2 here. If 2 is placed here, then 3 is naturally coming over here. And if I place 3 here, 2 will be appearing over here. And if you can see that none of the numbers are repetitive in nature. So the similar task I need to repeat. If the first digit is 2, if the first digit is 3, then what will be these digits? So if I identify this, the number of ways the first digit can be chosen is 3 different possible ways, and the number of ways the second 2 digits, that is the second and third digit, can be chosen is 2 different ways. So hence the solution for this case is, that is, I can have the first digit chosen in 3 different ways and the second and third digit chosen in 2 factorial ways, or which is indirectly the 2 ways. So hence when I multiply this, I'll be getting a total of 6. So what does this imply? This implies that I can have 6 4-digit numbers which are ending with 0. Now let us consider the second case wherein the digit is, that is the last digit is 0. 2. So in this case, what we have, the last digit is 2. So hence we have space for 3 digits. Now what are the 3 digits which are remaining? It is 0, 1 and 3. Now this is slightly different than the previous case what we are considering. Now since, suppose for example, if I choose a digit 0 over here, then if I consider say 1 and 3, then this becomes a 3-digit number. This becomes a 3-digit number and not a 4-digit number. So hence 0 cannot be the first digit out of the 3 choices what we have. So which are the remaining digits now? The remaining digits are 1 and 3. So what we have only 2 choices for the first digit. So which implies that we can choose in 2 different ways. So there are only 2 possibilities for the first digit. Now for the remaining digits, we can choose from the other 2 digits. So for example, if I choose 1 over here and 2 is already present, then I have possibility between 3 and 0 or 0 and 3, which can occupy the second and third digit. So here we have 2 different ways in which the remaining 2 digits can be chosen. So in this way, what happens is we have 2 different ways for the first digit and 2 different ways wherein I can choose for the second and the third digit. So hence we have a total of 4 digits which can be 4 numbers which can be formed with, which are ending with 2. So hence we have the final solution, that is we identified that the number of 4-digit even numbers that can be formed without repetition with the last digit being 0 is 6, and the number of 4-digit even numbers which can be formed without repetition with the last digit being 2 is 4. Hence the solution is sum of these two, which is 10. Hence the correct answer is 10 for this question. Thank you.